Okay, in this video we'll be solving exponential equations that have a base other than 10 RE. Let's look back at the procedures. If the base is not 10 RE, then what we're going to do is log on both sides. After logging, we'll apply the power property. And afterwards, we'll wind up dividing on both sides. Alright, so we've got 8 sample problems here. Again, we're going to solve each of the following round to the nearest thousandth. First one, 7 to the x equals 20. So it's time to deal with this base 7. Procedure says log on both sides, and then we'll apply the power property. 7 comes out, the x comes out in front, leaving us with x log 7 equals log 20. That actually means x times log 7. So because x is being multiplied by log 7, that's why we're dividing log 7 on both sides. That's why the previous situation said we're going to log, apply the power property, and then divide. Leaving us with x equals log 20 over log 7. If we were asked to find the exact answer, this would be our answer, log 20 over log 7. But let's go find the approximation. So we're going to do log 20. It's clear. There we go. Log 20 over log 7. Calculator says 1.5 some stuff. Let's go ahead and check ourselves. 7 to the answer. There's our 20. Which sounds like a reasonable answer because 7 to the first power is 7. And 7 to the second power, 7 squared, is 49. So definitely our answer had to be somewhere between 1 and 2. 1.539, nope, 1.540 if we round to the nearest thousand, 1.540. Second problem, 3 to the negative x equals 15. Let's get rid of this base 3 by first logging on both sides. Apply the power property, leaving us with negative x log 3. That says negative x times log 3, which means we divide by log 3 on both sides. Negative x equals log 15 over log 3. This says negative 1 times x, so it's time to divide by negative 1. So which gives us negative log 15 over log 3. So this entire expression will now be negative. Let's see what we get for our answer. Clear this out. So we're doing clear. Negative, there's our fraction now. Log 15 over, let's bring this down, log 3. Log 3. We get this negative 2.464, etc. Now, some of you may thought, well, hey, can we divide 15 and 3 and get 5? Well, let's check. Let's try it. Let's do negative fraction log 5. No, it won't be a log. Sorry, log 5. Here we get a totally different answer. So one of these answers is correct, one of them's not. Well, let's use this one. Let's see what we get if we check it. So 3 to the negative answer. As you can see, that doesn't give you 15. Let's go back and put in the negative log 15 over the log 3. All right, here we get this negative 2.46 some stuff. Let's substitute that if we check it. So 3 to the negative second answer. Bam, there's the 15. So it lets us know we cannot just simply divide these arguments here. Negative 2.465 will be rounded to the nearest thousand. Negative 2.465. All right, third problem. 4 to the x minus 7 equals 12. We'll take care of this 7 first. Add MEP, what's furthest from the unknown? There's the unknown, what's furthest is a 7. Add 7 on both sides. 4 to the x equals 19. Now it's time to deal with the base. Log on both sides and apply the power property. leaving us with x times log 4. Divide by log 4 on both sides. X equals log 19 divided by log 4. Let's see what we get. So let's clear this up. We got log 19 over log 4. Bam, 2.123-ish or 0.124 if I round correctly. Let's check first. So we're doing 4 to the answer. Move the cursor over. Minus 7. Bam, there's the 12. So our answer, 2.124. 2.124. Question 4. 5 to the x plus 6. Out of the two numbers, what's furthest from the unknown is the 5. That's why we will log first. Log on both sides, apply the power property, leaving us with the x plus 6 times the log 5. Divide both sides by log 5, leaving us with x plus 6 equals log 29 over log 5. One step away, simply subtract 6 on both sides. There's our answer. Again, this would be our exact answer. We want to find the answer to the nearest 1,000. So we'll let the calculator do that for us. That gives us, let's clear this up. There's my fraction. Log 29. 29 over log 5. Log 5. Move the cursor over. Minus 6. Get negative 3.908-ish if we round. Let's go ahead and check first. 5 to the second answer plus 6. Didn't really need to move it over. Bam, there's the 29. So our answer, negative 3.908. Negative 3.908. All right, next problem. 8 to the negative 2x equals 1. What's furthest from the unknown is this base 8, so we'll log on both sides and apply the power property. Gives us negative 2x times log 8. Because it's being multiplied, we're going to divide by log 8 on both sides. That leaves us with negative 2x equals log 1 over log 8. Divide by negative 2 on both sides. There's our exact answer. Let's go ahead and put this into the calculator to see what we get here. Now there's other ways you could have written this, because dividing by negative 2 is the same thing as multiplying by negative 1/2. So either way, you're still going to rely upon the calculator. So let's clear this up. There's my fraction, but the numerator is another fraction, so I'll press it again. So there we go. There's our log 1 over log 8. Let's bring this down all over negative 2. Calculator gives us 0. Hey, that sounds right, because 8 to the what equals 0? Sorry, equals 1. Any number except 0 raised to the 0 equals 1. Didn't expect that. Alright, so x equals 0. But if you would have thought about it earlier on, log 1 actually equals 0. Because 10, because of the base 10, 10 to the what equals 1? 0. Which means that would have left us with 0 over 8, which is 0, divided by negative 2, which would have still given us 0. So either way, if you had seen that log 1 can be simplified, it would have been a little easier to get the answer. But if not, calculator confirms. Next problem. 13 to the 2x minus 1. Out of the three numbers to get rid of, the 13 is what's furthest from the unknown, because both the 2 and the 1 are all part of the exponent with the x. So we're going to log first, and then apply the power property. There's our 2x minus 1 times the log 13. So therefore we'll divide log 13 on both sides, leaving us with the 2x minus 1 equals log 37 over log 13. 2 steps from the answer. Let's go ahead and add 1 on both sides. That'll give us 2x equals log 37 over log 13, all added by 1. Last step, divide by 2. So this gives us our exact answer. Let's see what the approximate answer is. All right, so we've got, let's clear this off. There's my fraction. Hit the fraction again. Log 37. Log 37 over log 13. Move the cursor over. Plus 1. Bring it on down. 2. So we get 1.204-ish. Let's check this. So 13 to the 2 answer minus 1. Bam, 37. So our answer, 1.204. 1.204. All right, last two problems. 7 to the 3x plus 2 minus 13. Add 13 on both sides, leaving us with 7 to the 3x plus 2. Time to deal with the 7, so we're going to log on both sides and apply the power property. That yields the 3x plus 2 log 7. More specifically, 3x plus 2 times the log 7. Divide log 7 on both sides, leaving us with the 3x plus 2. Time to take care of this 2. Subtract 2 on both sides. Then we'll divide everything by 3. So what's in green again is the exact answer. Let's go to the calculator. Let us show us the approximation. So we'll clear this off. Fraction. Log 5 over log 7. Move the cursor over. Minus 2 all over 3. Bam. Negative 390 some stuff. Let's go ahead and check this. 7 to the 3 answer plus 2. Move it all over. Minus 13. Bam. There's the negative 8. There's our answer. Last problem. We'll first, out of all of these numbers, we're going to take care of this 5 first. So we'll subtract 5 on both sides. Leaves us with the 9 to the 4x minus 3. Time to deal with the 9. Log on both sides. Power property brings the 4x minus 3 in front. Left with 4x minus 3 times the log 9. Divide that log 9. Log 1. We recognize this log 1 is actually equal to 0. So now we'll go ahead and divide by this log 9. Well, that makes things a whole lot easier. 4x minus 3 equals 0. Now we've got a two-step equation. Add 3 on both sides. Divide by 4 on both sides. There's our answer. 3/4, which is the same thing as 0.750 if we rounded it to the nearest thousand. So now those 8 guided problems. So right now is 8 independent practice for you.